Over the years, global warming has become an increasingly big issue, and while lots is being done to attempt to fix it, these attempts likely aren't enough. However, a new idea was presented a while ago that may have some promise. The idea of geoengineering, which is modifying the environment to reduce the amount of heat that is trapped in the atmosphere, either by reflecting it back into space or physically removing some of the greenhouse gases from the atmosphere. These ideas include spraying seawater thousands of meters into the air to seed stratocumulus clouds to reflect the sun's rays, or installing sun-blocking mirrors, or even injecting sun-blocking particles into space. However, these ideas require heavy machinery or massive amounts of materials to achieve the desired effect. However, an idea that stands out among the rest is to use algae to fix carbon from the atmosphere. This would be accomplished by seeding the oceans with large amounts of iron sulfate to stimulate algae growth. As the algae grow and then die, the carbon they absorb would be stored deep in the ocean, removing it from the atmosphere. Iron is a vital micronutrient for photosynthesis and growth. As such, very little iron could provide a massive boom in the phytoplankton population. This is due to something called the Redfield ratio, that represents the ratio of nutrients needed to support a population of phytoplankton. The ratio is 106 carbon to 16 nitrogen to 1 phosphorus, and recently the ratio was expanded to include iron, which would be 0.001 when compared to the original ratio. As we can see, a large amount of carbon is needed, which is readily available in the atmosphere, and tiny amounts of iron are required. For every 1 atom of iron, 106,000 carbon atoms can be fixed. With this ratio in mind, we can use stoichiometry to predict the amount of carbon absorbed for every kilogram of iron seeded in the ocean. The formula for stoichiometry is mass A times 1 mole of A over the molar mass of A times the mole ratio of B divided by A, which gives us the moles of B, which can then be converted to grams by multiplying by molar mass of B. If we start with 1,000 grams of iron, then we convert it to moles by dividing by 55.85. Then we multiply by the ratio, which is 106,000 carbon to 1 iron. Then we can multiply by the molar mass of carbon, 12.01 grams, to get the final number of 22,792,270 grams, or about 23,000 kilograms of carbon. This ratio is especially impressive when compared to the amount of machinery and materials that would be needed, just a boat or two and several kilograms of iron, compared to the amount of heavy lift airplanes that would potentially be needed to seed clouds to reflect some of the sun's radiation, not to mention the excess CO2 that would be released from such a venture. Iron seedings in oceans clearly seems like the simplest and most straightforward idea. But you may be thinking, why not just plant more trees? Wouldn't that also fix the problem? And you would be absolutely correct in thinking that. However, even though phytoplankton constitute just 0.5% of the entire biomass on this planet, they are responsible for 35 to 40% of the carbon uptake, which is about 150 billion tons per year. On the other hand, trees make up nearly 70% of Earth's biomass and absorb around 25% of the annual carbon uptake, equating to about 100 billion tons. This is mainly due to phytoplankton being able to occupy much more surface area than trees, and humans aren't constantly chopping down phytoplankton. The idea of iron seeding came into fruition in 2004 when the European iron fertilization experiment was conducted, where they seeded 160 square kilometers of ocean with 13 tons of iron sulfate. This resulted in an algae bloom that lasted 5 weeks, and afterwards a layer of dead phytoplankton 5 millimeters thick developed in depths below 1,000 meters. Because the phytoplankton are so deep, they are considered fixed, and the carbon will stay down there for thousands of years. However, contrary to our math and the Redfield ratio, for every 1 iron atom, only 13,000 carbon atoms were pulled out of the atmosphere, an 88% decrease in carbon absorption. This large reduction is because phytoplankton are part of the food chain and so large amounts of these blooms will be eaten by zooplankton and other small fish. The CO2 that was trapped in the algae will then be released back into the atmosphere, meaning it doesn't act as a carbon sink. This greatly reduces efficiency, as only the dead phytoplankton that reach the bottom of the ocean are actually considered as a useful carbon sink. While technologies and practices are likely to get better if this route is pursued, efficiency would likely still remain a key problem. However, there are some downsides to iron seeding. Researchers don't know all the harmful effects, but it is easy to imagine the possibly devastating effects of dumping such huge amounts of iron into the ocean where it doesn't naturally belong. There is a chance that these blooms will actually increase fish populations, as more productive phytoplankton growth will mean more food for the entire food chain. However, some people are skeptical that this would be the case, as instead it is possible that harmful algae growths would form, impacting the entire marine ecosystem. Though neither of these effects have been observed, overall, of all the geoengineering techniques, iron seeding is a relatively promising one. Though steps will need to be taken to carefully monitor the results of preliminary testing to determine if it is suitable for a larger scale. Hopefully, any type of geoengineering will not need to be used in the future, but at the rate we are going at now, it may become necessary.